Welcome to the 11th of 14 videos on the Arc Flash Truth No One Explains. My name is Joe Chacon. I'm the president of Podge LLC and Chacon Engineering. I'm a licensed professional engineer in multiple states and have been an electrical engineer for almost 30 years. Please like and subscribe as this helps us get this important information in front of more people. This video is going to walk through a special method for arc flash calculation with respect to current limiting fuses. Merson, who makes current limiting fuses, defines them as a fuse which will limit both the magnitude and duration of current flow under short circuit conditions. UL 248 gives it a more formal definition, and companies like Merson and Bussmann adhere to the standard. The two things to look for per UL 248 are clearing time in less than half a cycle, and the peak magnitude is clipped or limited to a value less than the available peak current. So, let's take a look at an example. Section H.3 from IEEE 1584 provides the empirically derived equation, and then table H.9 provides the coefficients. Assume we have a 600-volt system with vertical bus bars, which we know are referred to as VCB. We have 70,000 amps of bolted fault current, and we're using a 2,000 amp Class L fuse. The first thing to do is to see if we can even use the Annex H.3 equation. Table H.9 says if we're below 22.6 Ka or above 106 Ka, we cannot use the method. We also can only apply this for 600 volts, a working distance of 18 inches, and a VCB configuration. I expect the IEEE committee will broaden these tight requirements for future editions. But let's plug in the numbers for our example. We end up with 21.7 calories per centimeter squared. Annex H does not tell us how to calculate the arc flash boundary, but we know by definition it is the location where incident energy is 1.2 calories per centimeter squared. We can use a little bit of algebra to solve for this. We get 76.5 inches when we do the algebra. Is there a benefit of using the current limiting fuse from an arc flash perspective? Well, we would need to calculate what the incident energy would be if the clearing time was governed by a breaker's short time pickup, which would take about 300 milliseconds to clear this type of fault. We've done this math in previous videos, so I encourage you to reference those if you haven't seen them or if you just need refreshing. The answer is 34.5 calories per centimeter squared. So there is a benefit. Incident energy went down. I must say, this is a perfect segue to introduce you to the next video in this series, that being the topic of arc flash remediation. This topic is near and dear to my heart and is something I try to over communicate to my customers.